Hello, dear students. This is Tamás Jávor. Welcome back to Rubber Duck Physics. We have talked about how objects rotate and how we measure their motion. But now let's look at two special cases of rotational motion: uniform circular motion and uniform rotational motion. In uniform circular motion, an object moves along a circular path at a constant speed. The key here is that while the speed stays the same, the object's velocity is constantly changing direction because it's always turning. Even though the object is moving at a constant speed, its velocity is changing because velocity includes both speed, the magnitude, and direction. Since it's changing direction, we say the object is accelerating even though its speed isn't changing. To keep the object moving in a circle, there must be a force pulling it towards the center of the circle. This is called centripetal force, and it's always directed inward, towards the center of the circular path. The centripetal force changes the direction of the object's velocity, but not its speed. Without this force, the object would move in a straight line off the circular path. Now let's compare that to uniform rotational motion. In uniform rotational motion, an entire object rotates about a fixed axis at a constant angular velocity. Every point on the object moves in a circle, but the key difference is that we are now thinking about the whole object rotating, not just one point on a circular path. In both uniform circular motion and uniform rotational motion, something is moving in a circle, but in rotational motion, we focus on the angular velocity of the entire object, because there is not one value of linear or tangential velocity that could be assigned to it. There is an important relationship between the object's angular velocity and its linear velocity. The formula is v equals r times omega, where v is the linear velocity, r is the radius of the circular path, and omega is the angular velocity. Well, we saw this relation at circular motion, but it can be applied the same way to rotation if we pick one point of the extended object. The farther from the axis this point is, the faster it's moving along its circular path, even if the angular velocity is the same for the entire object. So, today we have explored two key ideas: uniform circular motion and uniform rotational motion. In our next video, we'll dive into accelerating rotational motion, angular acceleration, and the equations describing such motion. Till the next video, think about this. What happens when an object starts spinning faster or slower? In other words, how do we describe changes in angular velocity? I hope you found the video helpful. If you are aiming to master physics, I offer online tutoring for students in DP Physics, but also in A-level, by an exam board, and AP Physics. You can reach me via the email address listed in the channel description on the Rubber Duck Physics YouTube page, best viewed on a web browser. Do not hesitate to get in touch for extra help. Thank you for watching the video. See you next time.